Hey everybody, Mac here, and we are going to talk about how to divide with square roots, okay? So the way we divide with square roots, it's a lot similar to when we multiply. We have to make sure that we have a difference between what I call the innies and the outies, okay? So the best thing to do is just to start doing these. So if I take number one, by the way, this can all be found at maxtutorials.com. Lots of math there. Make sure to like and subscribe, ask questions, comments, do all that cool stuff. All right, let's start on number one. These are both in. So now what you could do, you could break down the 18 and do all that, but it's usually is going to work better if we reduce the fraction first. These are both inside, so I'm allowed to just treat that. What would it be if it was 18 over 2? You would just write 9, right? Okay, great. We divided 18 but divided by 2. But since they're both inside, this also has to be inside. And then if you could tell, square root of 9, we can do that. That's just going to be a 3. Okay, how about square root of 50 divided by square root of 2? Well, that's just going to be square root of 25, which is 5. Not so hard so far, right? How about number 3? Okay, 72 divided by 8 is 9. They're both inside. So my answer is inside, and my answer is 3. Next one, what's 98 divided by 2? Well, 2 goes in the 9 4 times with 1 left over. 2 goes in the 18 9 times, and they're both inside. So my answer has to be inside. So you can divide and reduce fractions and do everything you want to anything that's inside the radicals. They just have to stay inside. But now, square root of 49, I know what that is. Boom, that's that. Now, number 5. Now we start to get some outies. Okay, the 4 is not in play here at all. All I'm going to look at is the square root of 12 over the square root of 3. And I'm going to get the 4 has nobody to play with, so he just goes there. Square root of 4. Okay, and then of course the square root of 4 is 2. So I'm going to take the 2 with the 4, and it's going to become an 8. All right, let's go to number 6. 5 square root. Now go ahead. What's that going to be? 45 divided by 5 is 9. What's the square root of 9? That's going to be 3. So my answer is 15. When you have a number outside of a square root, it just means you're multiplying by that, okay? All right, let's do this next one. Now I can break down 200. I can break down 8, but I can also just divide it. How many times will 8 go into 20? Twice, with 4 left over. How many times will 8 go in the 40? 5 times. They're both in. My answer has to be in. What's the square root of 25? 5. Okay, and the last one here on this row. Okay, so the 3 is not part of it. Outies and innies can't mix. Keep them separate. Boom, and I get that. And when I pull out a 3, my answer is 9. All right, let's keep going here. Da, 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 da. So this one right here, rationalize the denominator. Now, we have not talked about rationalize the denominator is yet, so now we're going to talk about that. Okay, so now, first thing I'm going to do is I'm going to treat this like this was a normal fraction. I'm going to have a 6. Now, when I do the radicals, that's like 1 over 3, agreed? So this is actually going to become 6 over, now that would be a radical 1 over radical, radical 2, right? Sorry, I think I said 3. But what's radical 1? 1, so you don't really need that. So that's ultimately my answer. We got a problem though. We're not allowed to have a square root on the bottom. So we have to do something called rationalizing the denominator. So how do you get rid of a square root? Well, here's what you do. You multiply it by itself. Okay? When you multiply a radical by itself, what's square root of 2 times square root of 2? It's square root of 4. Okay, and this is 6 radical 2. But what's the square root of 4? Just a 2. Now I have 2 outies, so that 6 and the 2 can reduce, and it's going to be 3 root 2 is how you have to give your answer. So don't give your answer with any kind of radicals on the bottom. Okay, let's keep going here. Now I can't have the square root of 2 on bottom, so I'm going to square root by 2 over 2. And I'm going to get 5 root 2 over. Now, a square root times itself is that number outside of the radical. That's why we do that. That's how we get rid of it. So 11, if I want to get rid of the square root of 5, I'm going to multiply this by square root of 5 over 5. And I'm allowed to do that because what is square root of 5 over 5? It's just 1, right? You can multiply anything by 1, not a big deal. Okay, when I multiply across the numerator, the numerator is going to be 7 root 5. And then square root of 5 times square root of 5 is normal everyday 5. Let's go to number 12 here. So I'm going to multiply this by root 7 over root 7. Now watch what happens right here. It's going to be 3. Now I can multiply the innies, and that's going to be square root of 14 over regular everyday 7. So remember, when we multiply, outies can multiply with outies, innies can multiply with innies, okay? But outies can't multiply with innies. They have to stay separate. Boom, boom, and I am done. Okay, let's go to number 13. I'm going to multiply everything by a root 3 over 3. That's my 1. And I'm going to get 8 root 3 over normal everyday 3. And that is my answer. Let's go on to number 14. Again, I need to get rid of that radical on the bottom. So I just multiply it by itself. And I'm going to get 2 radical 66 over 11. Now, is there anything I can do? What some people will try to do is they'll try to divide the 11 into the 66. Don't do that. 66 is an innie, 11s are outies. They don't get to mix with each other. Keep them separate. 66, I already know from looking at here, is 11 times 6. 6 is 3 times 2. I'm not going to get any pairs out of that. So boom, I'm there. Number 15, okay? I'm going to square it. Now, what am I going to multiply by? I could do it by 2 root 3. Sure, I could, but why? I only want to do the root 3, okay? Because I don't care about the 2. I'm cool with the 2. That's fine. So I'm going to get 9 root 3 over, it's going to be 2 times, and what's root 3 times root 3? Normal everyday 3. And I'm going to get 9 root 3 over 6. But if you notice, I've got some outies here that I can deal with, and I'm going to get 3 root 3 over 2. A little better looking 3 right there. And let's go on to number 16. Rationalizing the denominator, I want to multiply by root 2, and that will give me, what is that? The 4 just stays there, but I have a root 5 times a root 2, which is going to be a root 10. And on the bottom, I'm going to get a 3 times a normal everyday 2, which will give me a 4 root 10 over 6, which reduces to a 2 root 10 over 3. And there you go. So that's a lot. We talked about how to reduce by keeping the innies in, and then we can finish things out. And then we did some rationalizing of the denominator. Okay, well, that's version A. I got some more. So if any of this is a little weird, check it out, and then I'll help you out. I'll see you on the next video.